Welcome to the Telepresence Deep Dive session. My name's Rafael Schloming. This is Luke Shoemaker.
Hi.
We both work at Datawire. Datawire, if you haven't heard of us, we make we make Ambassador, an API gateway built on top of Envoy, and we make Telepresence as well. So we are a group of brave individuals who've decided to build a company that builds developer tooling. So it's a fun job, scary at times, but this is some of the stuff we get to work on. So we're happy now that Telepresence is an official part of the CNCF since it's since last year now, and so we're excited to do this deep dive. So we're going to start with sort of project goals, how it works, and talk through some use cases, both real and imagined, aka some future roadmap stuff, and do a little bit of a demo at the end, and then we should have some time for questions as well. So I'm going to cheat a little bit here and make this dive a lot deeper by starting at a very high level. So what's the goal of Telepresence? Well, its goal is to give fast, high-quality feedback to developers, and this distinguishes it in almost no way from any other tooling related to software. We have lots of tools for this kind of thing. So what kind of feedback? Well, this is not a monitoring tool. It doesn't tell you what your code's doing when it's running in production or anything like that. This is actually a tool for giving you feedback on code changes. It's like a crystal ball that is trying to answer the question of what would the world be like if I press that big shiny red deploy button right now. And this is still actually a very broad goal because this is a big part of our job as developers. There are tons and tons of dev tools and techniques for doing this, everything from IDEs to integration test suites, and figuring out the right set of tools to use and keeping them, in a given problem domain, keeping them all up to date and everything. That's what we do as developers. And when we get it right, it's actually pretty awesome. I sincerely hope everyone has had the opportunity to work on an interesting project that gets this sort of thing right. Because when it's done right, it's a pleasure to develop on. But it's also one of the things that's sort of really easy to neglect or just get plain wrong. And sadly, I'm pretty sure we've all experienced that as well. So. And with cloud native development, this is actually getting harder and harder because what you're working on is distributed at many levels. The code itself is distributed across a bunch of different repos, probably written in different languages, maintained by different teams, probably runs on different networks, and all your services probably have different sets of external cloud vendor dependencies. And so with cloud native systems, you end up with this very unpleasant choice. Do I run my code locally for fast feedback? Oh, sorry. Do I run my code locally for fast feedback? Or do I run it remotely for realistic feedback? And having done this many times, I can tell you the answer. You run it locally using a build system that wires in just enough of the remote stuff that you need, and then as that set of remote dependencies starts to grow larger and a bit messier, you kind of update your build system as needed, and as that remote system changes, your build system starts to rot. And eventually you're spending more and more time keeping it all wired up, and you have less and less time for the real work of actually developing your application. Kubernetes and Docker Compose is a classic example of this in the Kubernetes domain. Adnan gave a great talk about this yesterday. They showed what Bitnami do with Telepresence to solve that problem. But Kubernetes is there's nothing inherently Kubernetes specific about this. If you have too many remote services to run locally, this can happen, and even when you're using even if you have sort of hermetically sealed Docker images for everything, you might get version skew between that version and the version that's running out there in the real world, and you get environment skew as well, right? Data is not something you can bring down locally to your laptop, and sometimes your code behaves differently with different data. And you don't even need to have 1 million services to run into this problem. One service with a webhook can totally ruin your day. So this problem is really pretty inherent to working on any cloud-native system. And if your approach to running stuff locally is to simulate its real environment, then you have committed to spending a significant amount of your life keeping that simulation up to date. So this is really the goal of telepresence: provide fast and realistic feedback without spending half your time fixing build system rot. So how does it actually do this? Well, we have a strategy for each of these goals. So to keep it fast, we run the code locally so you can use all of your favorite tools. To keep it realistic, we wire that code into a remote cluster so it's actually interacting with all of its real dependencies in real environment. And to keep it rot-proof, we use OS-level abstractions like the network, process, and file system instead of forking app-level configuration and trying to keep your code happy and your configuration up to date to cope with those two very different environments. Excuse me. I lost my pointer here. So let's take a closer look at how this works. So on the right, you have your code in Kubernetes. And as you can see, it's a very rich environment. And it gets richer all the time. So your code might be running in a pod. That container might have a bunch of secrets mapped into it. That container might also have a bunch of persistent volumes or volumes of any kind mapped into the container file system. There might be sidecars running next to your code in that same pod. And that code might have access to any other services running in the cluster or even services running outside the cluster. And any number of services in the cluster actually also have access to your code. And hey, it's 2018. Maybe some of those dependencies will actually call back into your code either directly or indirectly through other services. And this I'm sure feels dirty, but it happens. And if you're using single sign-on, some kind of OIDC or whatever, what's the other acronym? I forget it. But then you're kind of stuck with this on day one. No matter how small your app might be. So on the left, you have your code running on your laptop, which also has a rich set of useful things like a keyboard. But it doesn't have all the stuff on the right. So this is a problem. We need to solve this problem. And in order to solve that problem, we actually, what Telepresence does is it actually, when you swap the deployment, when you run Telepresence with the swap deployment argument, we actually replace your container with the Telepresence proxy. And that proxy then, working in cooperation with the Telepresence client, it proxies lots of stuff. And there's a lot of stuff going on here, so I'm going to break it down a little more. Let's talk about how requests get from the cluster to your laptop, and then we'll look at how the requests get from your code back into the cluster. What we do on the inbound side of the proxy here is we establish a reverse tunnel via SSHD over a kubectl port forward. And this lets us relay any incoming connections on the cluster side right down to your laptop. We use that same SSH section to pull down environment variables, and we can use we use SSHFS to mirror the in-cluster file system right onto your laptop. Now, the outbound part here is a little bit trickier. We actually pretty much need to hijack DNS and IP in order to capture traffic or capture traffic from your code back and direct it back into the cluster. And we do this via firewalls, IP tables on Linux, PF on the Mac. And this actually, we do this via something called S-Shuttle. You might have heard of that. And I'm going to get into that a little more later. But and then we use intercepting of DNS and IP to direct the write traffic back into the cluster. And there's another option here. You can also try to. It also has a strategy where it tries to use LD preload. We don't like to talk about this a lot because it's increasingly impractical. LD preload intercepts C library call, or is a way to intercept C library calls. C libraries change over time, so it's brittle, and more and more things are statically linked these days. So we tend to try and avoid that. That's pretty much the picture. It's kind of a complicated one if you start here, but if you build it up slowly, it's fairly straightforward. And so you now kind of understand how telepresence work. It's basically a really, really long extension cord that's pieced together with a lot of adapters. And when it works, it's actually pretty awesome. And on that ominous note, I'm going to switch gears for a little bit here and talk about what you can use it for when it actually works. So use cases that telepresence excels at. So one way to avoid the hard choices I talked about at the beginning is just to not develop locally. Actually run everything in a terminal section or a remote desktop. This is kind of the same idea as telepresence. Just plug in that complicated extension cord into your keyboard and monitor instead of into the OS level abstractions that we're working with. And doing this often involves giving up or avoiding some heavier weight tools that you might be more inclined to use locally. One of the early use cases for telepresence was developing, with those tools, with your IDE and your debugger. It's pretty easy to understand, pretty easy to explain. One of the things about telepresence is it's kind of a newish animal. A lot of the problems you run into in tech, you can just sort of you Google, you kind of find some solutions, and it's sort of things get popular really quickly. It's easy. Telepresence is, it's kind of like a microwave a little bit, right? It lets you do some things you didn't necessarily think about being able to do right off the bat. So this is extra popular with Java developers. They like their IDEs, and so there's a couple of tutorials on the Telepresence website you can check out. And we're always interested in contributions on the documentation front or integration front. If anyone has experience with doing any of these kind of things, we'd be happy to update the documentation or get more even get more sort of direct integrations contributed. So the another use case is full stack development. Sorry, I don't have a prettier diagram for this, but if you're hacking on a single page app that has server-side logic that sits behind an API gateway, kind of like most JavaScript hackers, you're probably so used to live file reload that the moment you have to wait for a compile cycle, you reflexively reach for a gulp of caffeine, and next thing you know, you're kind of way over caffeinated, and maybe you start frantically pushing bugs into production. Disaster ensues. And so with telepresence, you can actually swap out that Node.js app and get simultaneous live reload across the front end and back end. Now, just to be clear, some of the details of this might be imagined, but this is actually a real use case. This is something I've done myself, and it's pretty sweet when it works. Now, use case 3, webhooks. Again, this is one I've done myself. If you want to integrate with GitHub, something I've had to do, or Auth0, or your favorite social media platform, odds are you're going to run into a webhook. And webhooks can sometimes be sharp and pointy. And if you're using an awesome API gateway like Ambassador, plug, you can easily map that webhook into a dev deployment of whatever, into a dev version of whatever runs behind it, swap that out with telepresence, and hack directly on you know, the logic behind that hook while it gets called directly from whatever that remote integration partner is. Use case 4, automated testing with CI. So telepresence, you can use it inside your CI system so that your tests can actually directly use remote dependencies. It's actually pretty handy in a bunch of ways there. It ensures your sort of integration testing and your local dev environments are in much closer parity. And it avoids having to sort of overuse mocks, the falling into that. And not to say anything bad about mocks, they're good for their, they have good uses, but using them as a substitute for integration testing is not a great use. And so this is something you can do really nicely. You can, you know, run any you can run any code under telepresence, so you can run, you know, using your favorite unit test framework, but have access to all your remote dependencies. Use case 5. I'm going to talk about this one in a little more specifics because it is familiar to me. We actually use it internally for developing and testing Ambassador. But I'm pretty sure all the stuff we do would apply pretty well to developing any Kubernetes extension. So Ambassador, as I've mentioned before, it's an API gateway. It's built on Envoy proxy. It's integrated pretty deeply with Kubernetes. You configure it via annotations on services. That means it needs to watch for updates to services. It needs to be able to talk to services. It needs to be able to access sort of Kubernetes metadata, all that stuff. And so, you know, it's also an API gateway, right? It expects to run in a cluster. But we actually develop it on our laptops, and we use telepresence to do this. And when it runs on our laptop under telepresence, it actually behaves just like it's in the cluster. And it's pretty nice because we can have lots of services of different kinds deployed in the remote cluster. We can be hacking on Ambassador. We can run our tests against it, and we can actually, you know, when you're testing a proxy or an API gateway, it's really handy to be able to talk to it and to be able to talk to whatever it's talking to so that you can be sure they both give you the same version of whatever you're expecting to see. So yeah, we've actually been able to use this to speed up our dev cycle a lot. We used to have, I don't think, like a 45-minute test cycle. We've gotten that down to like under 5 minutes, I think, through this and some other things. But yeah, and again, this has that same sort of single source of truth effect. You know, you don't have sort of a different CI, different integration, and a different dev setup. So there's a reason that pictures like this exist. That's because adapters and extension cords are actually really useful. But we can improve this picture. So what are our plans going forward? Well, Telepresence does a bunch of useful things today. They're all built on proxying these areas, right? The inbound network, the execution environment, the environment variables and file system, and the outbound network. But we think we could do more with it. In particular, it always does all of these things at the same time, and we think it could be very interesting if these things were broken down into more of a toolkit. So telepresence is actually a bit of a mini monolith. You might wonder what exactly that is. Well, that's what you get when you take very, very dense code and have it also be tightly coupled with itself. It's kind of like I guess a neutron star, maybe a black hole, something like that. So the implementation is monolithic in that sense. The UI is monolithic, and we've actually started to decomposing some of the implementation so that we can actually build a better UX, starting with the outbound element of what it is proxying. So if we take a look at this picture, these are some of the updates we're working on. We've actually done much of the work for this already. We've built a replacement for S-Shuttle called Teleproxy. It builds on the same IP tables, PF abstractions, but it's kind of more of a domain-specific version, and that gives us a lot more control. So instead of just proxying an existing DNS, it actually includes its own DNS implementation, which can bridge to multiple different discovery sources and even override routing behavior on a per-name basis. And we've also started looking at a sidecar model for the in-cluster proxy rather than just evicting your deployed code entirely. And so this actually gives, these changes actually give us quite a bit of possibilities going forward. And what might we actually do with those possibilities to help users? Well, so for one thing, we can make telepresence multi-user friendly. One thing you may be aware of is that when you swap a deployment, it's kind of global, right? Only one person can swap a deployment at a time. And so you can work around this, but it takes a lot of work. You need to basically build out the tooling infrastructure, whatever, to either create per developer clusters, or have a have each developer have their own namespace, be able to roll out the app in that namespace. And so with a sidecar model, we could avoid the need to modify the cluster, the cluster at all, and simply shadow the execution environment straight to the laptop. And multiple users could swap the same deployment simultaneously. This would also make telepresence require less privileges because it doesn't need the ability to actually rewrite your deployments. Much of the setup could happen ahead of time, and you could use it in a much more locked-down environment. Separating the inbound and outbound means you could pipe inbound and outbound to or from different clusters. This might be interesting because you could potentially do something like shadow or dynamically route requests from a production environment or a production cluster, and then send the output from your dev code into a staging environment. That might be handy. One thing you could do with this is override remote services piecemeal. Send most outbound connections to cluster, but send some specific, remap some specific services to route to local Docker containers. What is it? Oh, yes. And so it could serve as an extension point for developer discovery. You could add in different bridges to different systems, because the discovery bridging, the bridging from discovery to DNS can be easily extended with a simple curl. This is something that's possible. I'm not sure it's useful, but you could do something like union clusters, where you, kind of like a union file system, but with Kubernetes clusters. You take the services running in two clusters and sort of run your code against an arbitrary combination of those clusters. So those are some things. I'd love to hear feedback on whether people think some of those things might be useful, because there's a lot of stuff there to build. I only want to build what people might actually want to use. But those are some of the things we'd like to the areas we'd like to be able to explore. But there's actually one more important thing we'd like to do with this decomposition. And so it turns out adapters and extension cords are actually kind of brittle. And to make it worse, when they break, it's not super obvious why. You often end up in one of those not sure whether to call a plumber or electrician places. And with this decomposition, we actually hope to make it more self-diagnosable when something's wrong. And we hope that will also enable some common use cases, even when some of the more advanced ones might not be available. So what's the holdup to actually getting access to all this good stuff? Well, telepresence is very environmentally sensitive. On the server, you've got different flavors of Kubernetes, different Kubernetes deployment options. And if that's not bad enough, on the client, you've got Linux versus Mac, you've got IP tables versus PF, you've got different DNS configurations, both on the laptop itself and in the network the laptop happens to live in. And laptops move around too, sadly. Well, sadly if you're a telepresence developer. So to give you an idea of how messed up this can get, I'm going to tell you a short story here. So when telepresence starts up, it needs to figure out whether DNS is actually intercepted correctly or not, in order to figure out when it's safe to actually run code. And we started out doing this by polling for a well-known name that we knew would only appear on the DNS server we set up in the cluster. And so this worked for a little while, but at some point somebody tried to run this code at a Starbucks or something, I don't know where it was, but where the DNS was set up to resolve everything, every name, no matter what it was, into an ad. So of course that didn't work too well. So we changed that. I think we changed it to resolve it to a specific IP or something like that. But hang on a sec. Right, as soon as we did that, we learned that Macs actually, sorry, not as soon as we did that. Sometime later, after doing that, we learned that Macs actually cache negative domain queries. This is very surprising to somebody. Well, I think it would be very surprising to anyone, but it's very surprising to somebody coming from Linux. I have no idea why, but they do this. So if it doesn't resolve, if a DNS name doesn't resolve the first time you query it, it's not going to resolve, well, for a long time, at least from telepresence perspective. So you need to flush this cache. And well, how do you flush this cache? It's funny you should ask. There's actually, and I'm not sure, let's see if I can show you this. It's a great little shell script for doing this. I didn't want to put it in the slides for obvious reasons. And I can't see, is that the right one? Next one. Yeah, so FAQ is great. I love this repo. It is super useful. It's not easy to find, but if you dig into the right places and run into this problem, you'll see. And if you take a look at that if ladder, you can see that that the way you actually flush the cache, the DNS cache on a Mac, has jumped back and forth between different, even patch versions, and there's that nice happy little shrug at the bottom of that else to inspire confidence there. So. Let me see if I can get you back to my slides. So, let me see if I can get back to my notes too. Yes, so what do you do? So at this point, we had learned more about DNS than anyone ever really wants to know. And what do you do with that, right? we'd like to write a test for it, but how do we actually write a test for it? You know, because there isn't an obvious way to write a test for this, we didn't really, you know, we have a whole lot of code that is sort of, has this kind of knowledge baked into it. And we don't want to change up that code because that code's running, it's working for a lot of people use it, we have a lot of users. We don't want to, well, and well, unfortunately that means to get from here to the grand future, there's going to have to be some disruption. And we don't want to go through that disruption if we don't have a good way to write tests when people do run into bugs. So that really is the problem that Luke here is going to talk about, because before we actually roll out this thing, roll out some of this grand new future stuff, we want to make sure we have a way to do it, to do that transition, that rollover manageably, to give people sort of good value for the disruption they're going to get, to make sure that they only get disrupted by a given bug once. So this is the problem Luke is going to talk about. And oops, sorry. If I can find my cursor. There we go. Here, I think if you hit, yeah.
Okay. Can you hear me? So we learned that a test case isn't so much what you would traditionally think of as a test case for us, that we have plenty of those. That we really need to capture these test cases that are individual environments. And that's very much a test case as much as what you would traditionally consider a test case. And so in order to take that statement a little bit literally, we wrote this new tool called testbench, which runs your existing test suite in a whole bunch of different environments, where it implements the environment as a VM that's been configured in a very specific way. So this is what that looks like. This is an actual report generated by Telepresence CI. On each row is one of our unit tests, and each column here is a different environment that we'd configured it to run the tests in. In this shot is a Fedora, a Debian, and a Arch Linux setup that are all set up a little bit differently. So how do we specify those three environments, and how are we going to go forward specifying more environments? Well, testbench contains a fork of something called make OSI, which is make operating system image. And from that, we've inherited this kind of neat INI-ish format for specifying how to set up these operating systems. But unfortunately, we have to augment that with some shell scripts. Then you have to keep these things in sync. And then as you add more environments, and if you make one change, you probably want to make it in several different other environments too. And so you have a whole bunch of files that you have to keep in sync, and you make the same change repeatedly. And it turns out that this isn't actually a great format. But we don't know what our ideal format even looks like yet. We don't know which things we want to be able to toggle freely, because when we find out a new bug, it's probably because it's something changed that we didn't think could change. But then on the same token, we don't know which things aren't going to change. We probably don't need to be writing that with network equals yes line every single time. And so there's a lot of inspiration of places we could look for what does our ideal telepresence developer experience look like here. Maybe still mostly looks like make OSI, just tweaked a little bit. Maybe it looks like Parabola's OSI make. Maybe it looks like Dockerfile, because working with Kubernetes, we're all very familiar with that, and just there's some comfort there. Or maybe we end up going super parameterized and end up mimicking Travis CI's matrix feature. We don't know yet. And so we need to figure out, we need to get input from developers working on telepresence before we have good answers there. Now, being able to easily add these tests isn't the only thing that's wrong with testbench today. For one, Mac developers can't run it on their machines, although that should be happening fairly soon. But also, we have really three layers that come into the environment: the local environment, your network, and then your remote cluster. And right now, telepresence is only or testbench is only trying to capture that local bit. Whereas Rafi was talking about, the higher bits very much matter too. You know, if you're in that coffee shop where DNS acts funny, we need to capture that in how we configure the network. And so that's a major thing that we need out of testbench that hasn't happened yet. And so that's not something wrong with it today. That's an exciting roadmap feature for tomorrow. But even then, we're not capturing the full local environment either, because we can't run Mac OS guests, which is another feature that should be coming soon. And so, and finally, we don't attempt to capture the remote Kubernetes environment too much either. Right now, it integrates with a service called Kubernaut that we run, which is ephemeral Kubernetes clusters for testing. But right now, Kubernaut doesn't have very many options for configuring that remote cluster. And so not only do we have to grow the testbench tool itself, we need to grow Kubernaut to enable us to test telepresence more robustly. And so these are all very exciting things that we are going to be working on in the future. And it's going to be a lot of work, and is going to require a lot of community contribution if we want to get this done on a reasonable timeline. Now, there are some community concerns with being able to contribute. So right now, if you came in as a new contributor, you're going to have a little bit of a rough time. After you've made a few contributions and have been maybe made a member of the Telepresence IO GitHub org, things get a lot easier, because until you're a member of that org, CI is basically non-existent to you. And there are a few reasons for that, because some of the tests haven't been fully migrated to Kubernetes with testbench, and they still need to run against a GKE cluster that you have to be worried about abuse for. And you have to do some things with Docker that we're worried about abuse. And so this is another thing that we have to do. This is even higher priority than any of the testbench things, because this will allow the community to really help build these things.
Nope. Thanks. So I'm going to ask you to bear with me for a second here while I change to mirror mode, because I'm not going to be able to type what I need to looking over my shoulder. But yeah, I'm going to show you a demo, well, network permitting of some of the new capabilities. Let's see. Let me make that mirror. All right, can you guys see what I'm saying? Oh, excellent. So, all right. And I guess I am on the network because I just used it to show that GitHub URL. So I'm going to run the teleproxy component here, and this is the component responsible for that outbound portion of what telepresence is doing. And this is, it's responsible for basically capturing the traffic that leaves your laptop and making sure it goes to the right place. Normally that would be a Kubernetes cluster, but it also happens to listen to locally running Docker containers. And I don't know if you know this, but when you run a Docker container, you can give it a name. So in this case, I'm naming it toes. And so this container is running now, and it's just running a simple shell. And if you note over here, I can type curl toes. It says failed to connect because, well, I'm not running anything. But if I run, I got that all right the first time. Yeah, so if I run a simple HTTP server there on port 80, go over here, curl toes, you can see I didn't have to do any port mappings. I didn't have to remember numbers. I didn't have to do anything. I can use the natural port 80 on the left, and I can curl right there from my shell on the right. And this is actually kind of handy. It doesn't even involve any external network or anything. It's all local. But if I kill this Docker image, you can see cannot resolve host again. And that would in fact happen on a Mac too, most likely, if you're running the right version, because that DNS is updated. But we also happen to be connected to a Kubernetes cluster, and you can see a bunch of services there. I'm actually gonna see if I can flip over to this. Yes, so this is actually the public thing that's running on that. It's actually the demo app that's running in our booth, and at the vendor area. You can actually go check it out if you want, and get a lot more detail. There's a lot more stuff there that's being demoed, but it's a single-page app. It's being served by Ambassador, and behind Ambassador is running a bunch of services that it talks to get quotes. Those quotes are getting streamed out here. So that's what's going on. You can see here we have the stream stable service. That's where the UI actually talks to get the quotes. We can curl stream stable and get the quotes ourselves. We're talking directly to the cluster. No port forwarding, nothing. Nothing needed. It's kind of like port forward on steroids. In fact, you get the whole cluster. I can curl Ambassador and see this is the HTML. This is the HTML getting served back directly from Ambassador as opposed to going through the exterior ingress path. And in fact, I can actually run that. I think I can run that. I should be able to. Yeah. Oop. Sorry, got a little type happy there. If I go to Ambassador here, I can see same thing running, talking directly to my cluster via teleproxy. So that's some of the things it can do now. We're eager to get this sort of available. It's kind of available. It's kind of available now. If you want to be a brave sort of new new user, you can actually run it through the released version of Telepresence if you know the right commands. But we didn't want to make it sort of default right out of the box because we didn't want to break people. So that's our demo. I think the other big testing thing for us is to get usability testing on sort of where we take sort of this decomposed thing. And so we'd love to hear from people, hear feedback on whether these ideas seem useful, whether some of the directions we're going get people excited, whether they want to contribute. So join our community. There's a lot of ways to get involved. You can learn more about the project. Check out the URLs up there. We have a Slack, so you can join the Slack by hitting that URL. Follow us on Twitter. And yeah, if you want to learn more about any of this stuff or learn more about Ambassador, come by the booth, talk to us, and we'll set you up.
Or come by the CNCF maintainer booth where I'm going to be hanging out for the next half hour.
Yes. Any questions?
Say more about how SSHD, what do you use it for, why the choice of SSHD?
SSHDs. It's actually kind of arbitrary. So a lot of telepresence, sort of the first incarnation, the pre-decomposed things we built from off-the-shelf components. So SSHD was just a handy image to use. It lets us do the reverse proxy thing. It can dynamically do stuff. Just like with the outbound part where we kind of use an off-the-shelf thing, but then ended up kind of digging in and using something more custom. I wouldn't be surprised if we did that with the proxy part as well. But yeah, basically it's we run the port forward that gets us into the cluster, and then we run the SSHD because SSHD can do reverse tunneling out of the box, and that's pretty much why. But there are half a dozen reverse tunneling solutions that could work. So. Oh, it's not. The
authentication we handle directly with kube control,
yeah.
the normal Kubernetes authentication. So we just totally ignore keys in authentication when talking
Yeah.
about SSH.
Yeah, so kubectl is basically your perimeter.
How about like service callbacks? When you call a service, but it calls back.
Yep.
How does that work with running locally? Is there a way to get that call back to your local machine?
So with Telepresence, yes, when you swap the deployment, you get it gets all the way back.
So even if there's multiple instances of that service, is there ways to trigger that?
So when the swap deployment happens, it replaces the actual, it replaces your container in the cluster with the proxy, right? And so the proxy hears about anything your code in the cluster would have heard about. So yeah, and it replaces, one of the ways it modifies the deployment slightly is it reduces it down to one, so you don't have the multiple instance problem.
Defined within Kubernetes and down to one, is that?
Yeah, exactly. Yep. Yeah, but looking at the sidecar option, there's some more interesting ways you could do that. You could do like per request routing and things like that.
So maybe it's going to change.
Yeah. Any other questions?
So you guys are talking about a sidecar option. Is that what's available or how will
We have some stuff. We have some early stuff. I would come talk to us at the booth, and we can sort of show you what we got there. So we're starting to play with some options there. So yeah.
Talk a little bit about people who use like custom codes to orchestrate services and transition.
I know people have done that. It is I believe it's a common use case. I've never done that personally. Maybe.
So your Docker Compose YAML looks mostly like your Kubernetes YAML, just slight differences. And so you've got that work of just keeping them in sync. And sometimes there's some mismatch with things don't quite work the same between Kubernetes and Docker Compose. And so that's just some overhead that's kind of silly to have to deal with. And Telepresence lets you just avoid that by just using the same Kubernetes YAML that you're using for your actual cluster.
Yeah, I mean, my impression of what people do there is, they already have two copies of everything anyways. They've got the Kubernetes copy and the Compose copy, and so they just stop maintaining the Compose copy and use Telepresence instead.
Anyone else?
That may well be a popular use case for Minikube too, since you get it all local there, run it in Minikube, and use Telepresence to wire in. Yep.
Yeah.
So you said it's possible to use teleproxy now?
Yep.
Where is that document?
It's an undocumented subcommand of Telepresence at the moment. So, like I said, we just released it out a few weeks ago, and so we've done internal usability testing on it. But we're like, we don't want to make more options. But yeah, you do Telepresence outbound, Telepresence space outbound, and you can play with it. And come grab us on Slack.
The documentation is Telepresence space outbound space -- help.
Yeah.
That won't come up if you just do Telepresence help, because we're considering it like a beta feature that we don't want in the general docs.
Well, and one of the things we want to avoid doing is making a monolithic UI with many options even more confusing. But maybe we have to. I don't know. But yeah, definitely, if you play with it, definitely come back and talk to us and let us know what what your experience is with it. I'm honestly curious. It's worked well for us. We use a mix of. It's worked well for us internally. We have a mix of Macs and Linux laptops. So, but we probably, I don't know, have only 5 different network configurations that it ends up getting run in. I'm sure there are way more than that out in the world. So, well, I'm hoping that the way we put things together is a little more architecturally robust, and so maybe it won't be as sensitive to network. different network configurations, but I would love some confirmation of that. Any other questions? All right. All right, thanks.
All right, thank you.